others. And then now we are back as usual, right? The holiday until yesterday, am I right? Hari Raya holiday.
Yes, Prof.
So today we'll continue again our lecture. Okay. So we'll continue on. We have done on chapter 1 and chapter 2. Okay. Is it clear, my voice, class?
Yes, clear, sir.
So how many of you are already in UTEM? Came back? Any of you already in UTEM?
Not yet.
Not yet. Oh, okay. So when you plan to come back?
Probably Sunday.
Weekend, sir.
Sunday. All right. Okay. The online until Sunday, am I right?
Yes, sir.
Okay. All right. So I already share my screen. Can you see my screen now? I'm at ULearn. Can you see now?
Yes, Prof. Yes.
All right. So I'm now at, if you open the folder on week 3, you can see, right, got lecture 3, lab discussion, and then hazard function and failure rate. Can you see that?
Yes, Prof.
All right. And can you see my screen or not? I'm opening my slide. Can you see my slide? Class?
Yes.
Nampak? Can you see my slide?
Yes, Prof.
Okay, so this is our lecture 3, yeah? Lecture 3. So we will discuss today on detailed architecture of a neural network. All right. So we have covered a few topics. Okay, topic 1 and topic 2, where we have covered on the introduction to neural network, as well as the history of neural network. All right. And then now we are going to go more detail on the architecture of neural network, where in this topic, we will cover on neural network architecture, neuron abstraction, mathematical modeling, and also activation function. Okay, so if you can see over here, there are many mathematics and statistics involved in this neural network. And also at the end of the class, you should know how the architecture work and some of the idea of the implementation of neural network using a computer. All right, is it okay, class?
Okay, sir.
Yeah. Right. Okay. Can this is neural network architecture. So it consists of a set of neurons, as I mentioned earlier. It consists of a set of neurons, and then the inputs are connected to each of the neuron in the input layer. Okay, and then the output are connected to each of the neurons in the output layer. So output connected to the output layer, and then it will be the input to the other layer. So they are actually interconnected following some patterns. All right. Okay. All right. Can you see I'm highlighting here the slide? Boleh nampak tak?
Yes, Prof.
Is it clear, my voice?
Yes, Prof.
All right. So big enough, the slide? Okay.
Okay, Prof.
All right. So neurons can be visualized through layers. So there are many layers. So we can visualize every layer. I will show. And typically neuron in the same layer behave in the same manner. Okay, so if same layer, same manner, means that if you use the activation function in layer 1, so it'll be same for all the neuron. Okay, all right. Okay, and then key factor to determine behavior, behavior of neural network are activation function and the pattern of weighted connection. Okay, And then the arrangement of neuron into layers and connection patterns are called as net architecture. Net or network lah, network architecture. So you can see we are trying to represent or trying to mimic how the neuron in human, and then we are trying to use mathematics to represent it. Okay, so if you can see over here, we have combined, okay, the artificial neuron and biological neuron. So if you can see here, biological neuron, there are many dendrites, body, exome, and so on. So we can represent these as the input as x1, x2, x3, x4 up to xn. And then every input, they have their respective weights. So you can see weight 1, weight 2, weight 3, up to weight n. Can you see or not, class?
Yes,
Can,
Prof.
doctor.
And then this is the summation lah. We have summation. So we sum up multiplication of all the input with their respective weight. So once we sum up, then we'll fire. So same goes to your biological neuron, right? So you have received many input from the signal to your brain, and then here we have some process. So you will sum up, you will see, is it you want to, are you thinking about it or not? If you are thinking about it, then you will fire, it will be input, and then you have combination of other input, then will fire some output, right? So from this input, it process with some axon here, or in the mathematics, activation function. So you fire output. Means that from the input that you receive here, you have combined, and then once you process, then means that you have learned something, right? You have learned something, you have some knowledge, some information. So this information will be the input for you to generate another output. Understand or not, class?
Understand, doctor.
Yes, Prof.
Right? So in biological, that's why that's how we think. So if the input, you get the input, and then you produce the output, or you have a data from the data in your memory, then you come out with the solution, for example. Okay, and sometimes maybe you want to remember things. You want to remember things in your mind, in your brain, right? So how you remember things? There are many ways, right? So in our brain, usually we call it as a web. We visualize something. We visualize it in our brain, and then we try to associate. Okay, that's why we have web over here. Visualize. You visualize something. For example, you bring your car into the supermarket, and then you park somewhere. So you have to visualize your car with the pillar. For example, that's why if you go to supermarket or big hospital, right, and then they have parking place, can you see or not? Uh, they have written there the number of the pillars. Can you see or not? Every pillar they have A1, A2, B1, B2, B3, and so on. Did you see that?
Yes, Prof.
Right. That's why you have to associate. You put your car, for example, your car number is M002, right? So you have to remember your car, and then you have to associate with the pillar and the pillar number, maybe P3 or P4, P5, and the pillar number. All right, you have to associate, and then you must have a pleasure. Why you associate? For example, if you go to KLIA, you park your car at KLIA 1. So you know that you are going overseas. For example, you are going for vacation to Europe, right? So you want to come back, and then you take back your car, so you have a pleasure to remember, because you want to get back your car once you come back from overseas, right? So that's how we do. So we visualize using a color. So if you have color, and then you store in your mind, then easy for you to recall. Then the motion, and then must be big. You have to store in your memory with a big image, right? and then with some strange, for example, if you want to remember people name, so you have to associate their name with something which is strange so that you can recall next time, right? So that is on biological, right? So in the mathematics, in artificial, you can see there are a lot of, they convert it into the number. All right. So we have input one, input two, input three, into number. And then we have their respective weight, maybe 0.01, 0.03, 0.04, and so on. Also the number. Then we have product, x1 times w1 is the multiplication. Again, you get another number. All right. After you get the number, then you have to sum up x1 times w1 plus x2 times w2 plus x3 times w3. And then when you sum all this, again, you get another number. So in artificial neural, we play with the number. Whereas in biological neuron, you play with visualize something and then you associate, and then you have a pleasure to store in your mind or in your thought using color, motion, and then big image, strange things, and so on. All right, that's how you store in your mind. All right. Right, now we want to see how neural network used, and then we want to see more detail on this architecture of the architecture, and also all this weight. Okay. All right, now we want to see on the neural network taxonomy. The typical architecture actually is the from point of view of the active or decoding phase. Artificial neural network can be classified into few architecture: feed forward, feedback or dynamic, or recurrent system, as I mentioned last week, right? And then we have to set the weights. Next, you have to set the weights. So from the point of view of their learning or encoding phase, artificial neural can be classified into supervised and unsupervised system, where we will see later on. All right. So this is the typical architecture. You can see nodes are partitioned into subset, which called layers. So we have layer 0, layer 1, layer 2, layer 3, right? So in layer 1, this is the input layer. You receive the input, and then you will go to the next layer, and then go to the next layer, and then finally fire the output. So in between this input layer and output layer, it is the hidden layer. We call it as a hidden layer over here. Okay. So input from the environment, you get input from the environment are applied to nodes in layer 0, input layer. All right. And then nodes in input layer are placed on holders with no computation occurring, where the node function are the identity function. Means that at the beginning, at the input layer, no mathematical calculation and so on, right? You will get the raw data or raw input, right? Like same as your memory. When people teach you something at the beginning, your knowledge, you don't have any knowledge about that particular field. But later, when you receive the information or the data, then you process the data, then you come to the subsequent layers and so on. All right, class? Okay, so from here, we can see this layered network, right? We have input X1, and then we have hidden neuron 1, and then until we have output neurons. So from here, from this architecture or this topology, network topology or network architecture, we can convert into this form, right? So you can see X1, then we have hidden neuron over here. So the hidden neuron can be 2 layer, can be 3 layer, 4 layer, and so on. It depends on the complicated or complexity of the problem that we face or the issues that we face. Okay, so you can see over here we have X1, X2, and then we have hidden neuron. Uh, we can have layer 1, layer 2, layer 3, and so on until we fire the output over here, and then this is the output which is equal to Y. All right, that's why you can see over here. We have X here, and then it will fire the Y. In between, we have a lot of hidden layers. All right, okay. And as I mentioned last week, you can see over here, this is the network architecture. So we have single layer, then multiple layer. This is one way. Okay, this is one way. And then if you can see recurrent, it can go back. You can have a looping over here, right? So here we don't have hidden units, only one layer. Then in fire output, but here we have many hidden layers. Okay, you can go to layer one, layer two, layer three, and so on. All right, are you with me, class? Can you see this architecture?
Yes, Prof.
All right. Okay, so this is the single layer net. Okay, you can see over here there are many types of layer. All right, we have single layer, so we want to see single layer. So in single layer, it has one layer of connection weights only, right? And then the weight of input do not influence the weight for the output units. Means that you have one flow over here, input, and then with the weight, and then you will fire the output. All right. So this weight is not related to the next neuron weight and so on, right? So we call it as a feed forward nets. Okay, feed forward nets where means that one way lah, one way. The signal flow only from the input units to the output units in a forward direction. So there is the single layer. All right. Whereas if you compare with the multiple layers, right, it has one or more layers. So we have layer, and then we have another layer, then only will fire the output, right? So it has one or more layer of nodes or hidden layers between the input and output units. Okay. So hidden refers to the neuron is not directly seen from either input or output of the network. All right. And then by adding, if we add more layer, so there will be more calculation, more statistical calculation. All right. Uh, like here lah, you have more layer, so this is one layer, you have calculation. So once you have the calculation, go to the next layer, calculation, the next layer, calculation. So you can see layer one got one calculation, layer two one calculation, layer three one calculation. So it will be higher order of calculation or statistics. Okay. Science input to process all that calculation. All right. Can you understand or not, class?
Yes, Prof.
Right, you can see over here, right? So we input a first layer, you already have calculation. Then go to the second layer, calculation again. Third layer, calculation again. So if we have 5 or 6 layers, then more complicated the calculation. Later, when we see in the lab on the calculation part, then you can see how complicated of the calculation, right? Okay. Right. But for human, if you have calculation, if you have mistake here, like your mathematics, right, you have learned about the derivative, first derivative, second derivative, third derivative in your mathematics calculus, right? So if you make mistake at the first derivative, then for sure second and third and fourth derivative, you will have more mistakes, right? But when we deal with the computer, we ask computer to do calculation. So the error or the calculation is very accurate, right? That's why we can make use of the computer to come up with the complex calculation or metrics. All right. Okay, this is the recurrent layer. You can see over here. So just now you see this is from left to the right, and this one from bottom to up. How you know left to right or up to bottom to up, class? How you know? This is left to right or bottom to up? How you know? Class, are you with me? How you know? We want to know bottom to up or left to right or right to left or top to
Chưa hiểu.
bottom. Yes. So you look at the arrow, right? So you can see here starting. This is starting point. Arrow from left to the right. So you know this is the input and this is the output. So here, if you did not, I did not label the output, you should know, right? Because it start from the bottom, the arrow go up. So this is the input, and then it go up, and then
Okay, now close the focus. Yeah.
this is the output. All right.
Now we
And also you can see at the flow diagram over here, the input, and then you have hidden layer, and then the output layer. Any question, class? Just now I heard something. Do you have anything? Do you have anything to ask? Ask. Hello.
No, sir.
What? Okay. Right. So if you can see over recurrent, you can see over here, and it has looping also. This is looping. Yeah? So means that this is the output, but this output is actually input to the same output again. All right. Okay. Same like people lah, they uh, we ask the people for the clarification, right? So once they answer, so that will be the input for us to think again deeply uh, uh, on the solution and so on. All right. Okay. So this is the recurrent network where we can convert this diagram into the flowchart, and then from the flowchart you can convert into this model. Okay, you can see over here we have initial condition, so we have sets of input, many input. All right, you can see over here many input, and then we have three current layer, means that is the input for this one, and then it will fire the output, or it will be the input again, right? So again it will use the weight to multiply with the input and then produce the output again. Okay. Now let us look at feed forward and feedback network. Okay. So this is a feed forward, means that one way, but this one we have feedback. He go and then he come back to other node, can come back to other node. Okay. So feedward architecture in which the network has no loops. So over here you can see that no loops. Am I right? No loops. Can you see or not? This is a feed forward heterozygote, right? No loop. Whereas for B, you can see there are loop feedback heterosociator. Okay, and then another one is a feedback heterosociator. Okay, so feedback recurrent architecture in which loops occur in the network because of feedback connection, right? So we have feedback, we have answer, then we process the answer. For example, I give you assignment, then you ask to get more clarification. You want to know more detail about the same assignment. So I give you more instruction, more instruction. So it's as a looping. Okay. All right. So now we are at feed forward network or feed forward nets, where the signal flow only from the input units to the output units in the forward direction. I have mentioned just now, same thing, right? And then next we come to the feed forward supervised network. Okay. All right. This network I typically use for function approximation tasks. Okay. We are very clear on the function that we are going to use. So we call it as the supervised network. Okay. The example of this feed forward supervised is linear recursive lean mean square networks, and also back propagation network, and also radial basis network. This is a few types of neural network, right, that we will learn later on back propagation topic, radial basis topic, and so on. Okay. All right. So this is the example. Later you will see more detail about this network. All right. All right. Next is unsupervised network. These networks are used to extract important properties of the input data and map input into a representation domain. So we have certain domain. For example, we have cluster A. How cluster A? It looks like this. Cluster B looks like B. Cluster C look like C. So we try to map the input that we have into which cluster. Either it belongs to cluster C or belongs to cluster D or belongs to cluster B and so on. All right. And there are actually two basic group of method belongs to this category. All right. Which is the first one is the Hebbian networks performing, which we call as the principal component analysis of the input data, also known as the coherent loop transformer. And another one is a competitive network used to perform learning vector quantization or tessellation of the input data. Okay, self-organizing map or coherent feature map also being to this group as well. Okay, all right. Okay, right now in the feedback networks. Feedback networks is exist in dynamic system whenever the output influences the input, right? I give you the, for example, I give you assignment. I tell you, okay, your assignment, the expectation, the output supposed to be like this. All right. So when you ask more detail, then I will give more detail about the assignment. Then you see that you need more data, or you had to get more information about the assignment to produce the result or output, right? So that's why it's become dynamic, right? Any question, class, so far?
No, doctor.
No, so it's play major role in recurrent network or neural network. Okay, all right. This network are used to learn or process the temporal features of the input data and their internal state, which evolves with the time. Because when at the time A, for example, now I give you new assignment at 8:30, for example, and then I explain about the assignment, and then at next class you ask again, right? You want to know to get more clarification about the assignment. So at that class, which is already at time B, so time B I give more detail. Then time C I give more detail. So it's associate or it's evolved with the time. Okay. Specific example for this is a recurrent backpropagation network, associative memory, where you associate something with something, right? And then another one is adaptive resonance networks, all right? So that's about the feedback networks. When you look at the uh, network, you can see over here is the weight. All right, it's the weight. So now we want to know what is the weight. Something about the weights. Okay. So weight understanding, actually we want to adjust the weights to learn a given target function, y equal to fx, right? So if we given y, this y equal to fx with the function of this network includes the weights and then the hidden neurons, right? So this is how we adjust the weight. Sometimes for supervised learning, you already know the output supposed to be like this. For example, character A, you already know character A is like this, small a, right? We already know. So that's why we call it as the supervised learning. We already know that character U is like this, right? U, right? So if we write U, if your U is wrongly you write or you give to your younger brother, for example, to write U is very small, just learning or writing the alphabet. All right. So you ask to write U, maybe we have a different shape with the error, right? So then you correct again. You correct again. You tell again. U is like this. You correct again. So you give more adjustment to him. It's some sort like adjust the weights until he come up with the perfect U. All right. So that's the example on the supervised learning. You want to teach on the U understanding. So you already know the target Y. Y is U, how U looks like. So you teach your brother or younger brother or younger sister how to write U. Right? So how we set the weight? The method of setting the values of weight training is an important to distinguish the different neural nets. Okay. Training is the act of presenting the network with some sample data and modifying the weights to better approximate the desired function. That's why I told you just now, if you want him or her to write U, so when he write U in the wrong way or wrong format or wrong shape or wrong direction, then you train again. Okay, you show again, right? Until you minimize the error where the function of this way is reduced to error between desired output. So when you are happy with the shape or uh, the shape of the U, all right, then it's already the error at the minimum level. Okay. All right. Now we come to the supervised and unsupervised, the training type. Okay, supervised is supply the neural network input and the desired outputs. Okay, it's response of the network to the input, which is measured by modifying weights. As I mentioned, modify weight to reduce the difference. We want to reduce the difference between the actual U and the desired U, our output that we want. Okay, and it typically for pattern classification problem. Okay, this is supervised. Typically for pattern, like I told you, A have their own pattern, B have B pattern, C have C pattern, D have D pattern. Can you see or not different pattern of A, B, C, D class?
Yes, Prof.
That's why we can read over here. We can differentiate S with U, with P, with L, with I, with E, S, and when you combine, we call it supplies, right? So because we can see each character have different pattern, and even we know which is big S and small s in this word, right? So it is one pattern classification. Whereas in unsupervised learning, it only supplies input and no target output. We don't know the target, how it looks like, right? The neural network adjusts its own weight so that similar inputs cause similar outputs. The network identifies the patterns and difference of the inputs without any external assistance and typically used for the clustering. We want to cluster. Okay, so this is unsupervised. For example, we know this shape, we know this is the lake, okay, this is the forest, okay, this is the sky, this is the sea, this is the river. So they have different cluster. All right. Okay, now we are at the neuron and activation function. All right. So neuron abstraction, neuron transduce signals electrical to chemical and from chemical back again to electrical, right? So in our brain is like that. It's the electrical pulse. Okay. So from electrical, it come to chemical, and then from chemical back again to electrical. You can see over here, all right, in this axon or neuron architecture. Okay, that's how the signal flow in our mind, and each synapse uh, associate with what we call the synaptic efficiency, and then the efficiency with which a signal is transmitted from the presynaptic to postsynaptic neuron, right? So we can see. Now we want to transfer this to this form. You can see over here. So we have S1, S2, S3, whereas in our neuron it's only electrical to chemical, and then chemical back to electrical pulse. Okay, and then it transfer or transform into this model where this is something like this. Okay, so we have J artificial neuron that receive input from S from possible and different sources. So we have here SJ. So S is the input, SI, XX, xj, is the xi, x1, x2, x3, x4 up to xj. All right, and then we have bias over here, and then our fire the output. All right. So an internal activation function xi, which is a linear weighted aggregation of the impeding signal modified by an internal threshold modifying trending value. Okay. So you can see over here xj equal to summation. This is the same formula. I'm repeating same thing like what I have mentioned in last few weeks, right? Where we can see the connection of the weights over here is actually the synaptic efficiency of various interneuron synapses. Okay, so we have different synapses. Okay, so in this synapse we have different weight, and then the second one different weight, and then up to the nth synapse is the different weight. Okay, all right. So we can see over here Wj denotes the weighted from neuron I to neuron J. Okay, and then we have this multiplication. All right. So this is from the biological to the artificial neuron. Are you with me, class? Can you? Hi.
Yes, Prof.
All right. If you look at the biological, it's like this also. You can see this is the, for example, we want to remember things. Okay. Can you see? I try to put slideshow. Can you see my slideshow?
Yes, Prof.
You're right. Slideshow. Okay. So this is things how we want to, we will remember things, for example, right? So, for example, if you look at the mnemonics, how we remember things, right? So we can see over here how we remember things. We use the steps to visualize something, associate, and then we have a pleasure. All right. So this is the example. We use the color, motion, and then with the big image, there's something very strange we put in our memory, in our brain, then easy for us to remember. Correct or not? Hello, class. How you remember your friend name? You meet new friend, and then you shake hand during Hari Raya, for example. How you remember his name? Class. How you remember your friend name? Or someone that is strange to you, first time you meet, how you remember his name?
Like take context like that. Contact details.
Contact detail, correct? All right, but there is the number, but easy for you to remember by looking at the face, so you can see how the face looks like. Correct, not? Is fair or not, or is dark? Is hair straight hair? He wears spectacle or not? Right, not?
Yes.
Yes. So he wears spectacle, so you try to associate name. His name is John, for example, and then you try to associate his face with his name so that next time when you see again, you know, oh, this is John, right? That's how we do. All right. Other than that, we try to repeat. When you say, hi, I'm John, then you repeat, oh, hi, John, how are you? So you repeat his name. Why you repeat? Because you want to store in your mind. Right, not? Right, not?
Yes, doctor.
Right? Other than that, emotion, you see how is emotion or emotion. And then when you talk to him, how he pay the attention. So he's very interesting person to you or not. If he's a very interesting person to you, then you will try to communicate further. Then it will store deeply into your mind. Otherwise, if nothing to you, then you won't remember for long. Huh? Uh, you won't remember him for long. So the weight is not that strong to hold his information in your mind. Okay. Other than that, the process, you want to make sure that things store in your mind. You try to register in your mind, like your subject. Yeah, you want to take exam, you try to memorize, and then you try to keep in your mind so that it will be in your mind until the exam day, so that you can recall back all that. Right. So the process to put in your mind is you register, and then you retention, and then you retain all the information in your mind, and then you try to recall. So which one is more important? Register, retention, or recall? Class? Can you see my cursor or no? Class?
And doctor.
So which one is more important? Register, retention, or recall?
Register.
Register is the most important one, correct? Huh? Because if you fail to register correctly into your mind, then you will fail to recall. You somewhere in your mind, you store somewhere in your mind, but if you did not register correctly, so you cannot recall. Understand?
Yes, doctor.
Same like the file lah. You have one file, I email to you, then PDF file, then you have to save in your hard disk with correct name, right? If you did not put the correct name, so later you will have difficulties to find that file again. Or if you manage in the folder, you must make sure that it go to the correct folder, so that easy for you to recall back, right? But if in computer easy, you just search file name, and then you will go to the specific folder and take. But it's not same like in your mind. In your mind, you must store correctly, right? Because in our mind, we cannot create many folder like what we create in the computer, right? So you have to create the folder or the space in your mind for certain things, and then you have to manage properly in your mind so that easy for you to recall again, right? So that's why people when come to the recall, they try to before they sleep, they try to call back again what they have experienced every day, so that it will be stored from the short-term memory to the long-term memory. So they try to every day repeat it, and then try to recall again what happened every day in their mind, and then when come to the week, they try to before they sleep maybe they try to recall back what happened the whole week, and then what happened the whole month, what happened to the after the 6 months, for example. So this is how they can store their memory. That's why you can see some people, they can recall back what happened even after few years. They can explain like what it's happened at that time, right? Uh, and they also use anchors. For example, they have pack system, alphabet, how they remember A to Z, how they remember number, and so on. All right. And then if they go to the tour, they want to know which they're supposed to go left or go right, and so on. Then they try to associate things with something. For example, left, they try to remember the leaf. Okay, the right, they try to remember the rat or the mouse, for example. The rat, right, it's run to the right, or it's go to the left, and so on. Right. So this is all the mnemonics, or how people remember things, numbers, characters, and so on. Okay. So same goes to the this architecture. All right. If you can see over this architecture, we have to represent everything with the number. So this one also in the computer, it will stored with the number when it goes to the data in the table in your database. So it already have their unique identification, or and then based on that particular table, row I, column J, So you know already what is in Xij, what is in X11, what is in X13, what is X in X31, what is in X41, and so on in the table. Okay, so from that we can process to the next level. All right, how we process this? Now we are coming to the mathematical modeling, more detail, how we convert this into the mathematical modeling. Class, are you with me?
Yes, doctor.
Okay, right. Back to here. Okay, now I'm going to, can you see my ULearn class? Nampak tak?
Can, doctor.
Can see, yeah? All right. So in my ULearn, if you can see over here, I already put the semester survey. Have you done that? Anda buat tak semester survey? Can you see beginning of the semester survey? Pre-course assessment. Have you done? Hi class, are you with me, all of you?
Belum, sir.
So by right, you should do beginning of the semester survey. Okay. This is actually, can you try to click? Boleh? Boleh buka tak?
Boleh, doctor.
Yeah. So this is at the beginning, your knowledge about neural network. By right, at this time, your knowledge is kurang lah sikit. But at the end of this class, I will give you end of the semester survey. So by right, your knowledge should be improved lah. But if your knowledge is less than what you have now, there's something wrong with you. Correct or not? You understand what I'm saying? Do you understand what I'm saying?
Yes, sir.
Yes, doctor.
I know. For example, I'm able to relate various method. So by right now, maybe at the number 1 or number 2, later supposed to be at number 4 or number 5. But now already number 5, then later you put number 1 is something wrong. You must know how to do this survey, right? At the beginning, your knowledge is maybe less, but after you finish this class, you will have better knowledge about the neural network. Am I right? Am I right?
Correct, doctor.
Yes.
So now can you take your time, do it? I give you maybe few minutes to do it, 5 minutes. Is it
Okay,
okay?
doctor.
Until 9 o'clock. Please do this survey. Okay, I give you 5 minutes to do the survey until 9 o'clock. Is it okay? Hey, class, have you done survey?
Yes, doctor.
Okay, good, great. All right. Now, let me tell you about the absent from class. If you absent from class, so I already create the folder. So you must have the hard copy of MC, appointment letters from the faculty or other official documents. You have to give me the hard copy because I want to put in the file. And then the soft copy you can put over here. You upload here, the soft copy. Hard copy you have to print and give me one because I want to put in the file. Is it okay, class?
Okay,
Okay,
doctor.
If you have a problem with the health and so on, so make sure you have MC. All right. Okay. What else? Okay. Week one. Okay, for those who absent before. Okay. So week one actually we have covered on the introduction to neural network, right? And then in week two, I have gone through more on the lecture where we can see over here we have covered on the basic structures of neural network as well as some of the important terms as well as the history. Remember, class?
Yes, doctor.
All right. And then when you look in week one, I have given you the lab work challenges in computerized system development, right? But I can see that there are many students already submitted, more than 100, but still I can see that many did not submit this lab work. So you should know lab work 2 also more than 100 is good, but still many did not submit your lab work. Can I know why? Class, why you did not submit? Hello? Hello, are you with me? You see, lab work last week one, you see, or less, huh? Only 60 something, not even half. By right, you should do this during your lecture, your lab time. Am I right? Betul tak? Saya dah beritahu kan?
Yes, doctor.
Yes.
This one also not even half submitted. So I want you to do this and then submit the lab work. Can you do it, no? Class?
Yes, doctor.
So I will extend. Sekali lagi ya, saya tolong extend until next week. Lepas ni saya dah tak extend dah. Allow submission 20 until 11 until 12 April. Okay. So please submit, huh? Please do and submit. I don't know why you did not do. Can you do it, no?
Yes, doctor.
Class, and then the lab 2 also, see, many did not submit yet. Can you see my Yulen? My Yulen? Boleh nampak?
Can, doctor.
And then, okay, so give me some time to extend. I want to extend like this next time. So please. This is the problem with the student when they get low marks, then they are asking for better grade. But when give work, no one to do. So you should do. You're at home, so even you're at home, you must complete your work. Is it okay?
Okay, doctor.
12 April. Okay. So week 2, and then this is another lab work. Don't simply copy and paste or just simply use ChatGPT. You must know what are you doing. Okay. You must learn. All right. I'm done. Okay, back to week 3. Okay, now I'm at week 3. Okay, so all right. So today is our lecture. Am I right? Today our lecture. Can you see my calendar or not?
Yes, doctor.
Kan? Okay. Today is our lecture, and then by right our lab next is our lab on Monday. Am I right? And Thursday. Today, right? Today afternoon we have lab, and Monday also we have lab. Am I right? Betul?
Yes, doctor.
All right. So for the lab session, I will give you work, and you have to do the field work because many did not complete week 1 and week 2 lab. I want you to do that during our lab time. Can or not? All
Can,
sections.
doctor.
Section 1, group 1, section 1, group 2, section 2, group 1, and section 2, group 2. So during the lab, I give you field work, and I want you to do that. So no lab this afternoon. I want you to use that 2 hours to complete all the field work that I give to you. Many did not do it yet. Boleh?
Boleh.
Yeah. And then next week on Monday, I get to know that there are still students couldn't get the ticket to come back, and there are some coming back on Monday. Am I right? Betul? Because Sunday ticket, they don't get the ticket. Am I right? Is it correct? No?
Yes, doctor.
So Monday also during our lab, I want you to do it by yourself. No lab session face to face or online. During lab, I will give you work to do. Can or not?
Can, doctor.
Can
Okay,
So
doctor.
our next meeting will be face to face on next week Thursday, 10 hari bulan. Can or not? 8 o'clock.
Yeah,
Our next
doctor.
meeting. All right. So for this week lab, what you have to do, all right, if you look at the lecture before on the history, okay, all right, so what you have to do, I have discussed with you in lecture 1, all right? Remember on the very brief about neural network, you remember or not in lecture 1? Very brief about introduction about neural network, remember or not? Lecture 1?
Yes, doctor.
Okay, and then after that, I brief you about the history of neural network, artificial neural network, Pitts and McCulloch, and then Herbian, early booming of neural network, okay, and then the setback and so on, right? Remember?
Yes, doctor.
Okay, and then we have covered the history of artificial neural network until 1988, around that only, 1988. Betul tak?
Betul, doctor.
So now what I want you to do, this week lab, you have to study on history of artificial neural network from 2020 until now. Go to Google Scholar, go to YouTube, go to Google, and then find the detail history of more detail of recent history of neural network from 2020 until now 2025. Can or not?
And doctor.
So this is the lab work for this week. All right. And then I also put here lab discussion on the technology and artificial intelligence, AI. Can you see or not? Class?
Can, doctor.
Yeah, doctor.
All right. So what do you understand about this technology? Today, there are people using a lot of technology. So is it good or not? What do you understand from this picture? Nagulan is here, Nagulan? Hi, Nagulan. Nagulan is here?
Yes, bro.
What do you understand from this picture?
Sorry, bro. I can't see the picture.
Yeah, you can see the picture?
Yeah, bro.
What do you understand?
So in my opinion, I would say technology is more like a knife. It has both the users and also has its own disadvantages. So it depends on how
Okay.
we handle the technology itself.
All right. In another way, you can see that without technology, last time people used to communicate, and then they pass the information from one to one, and then they distribute the knowledge, right? But with the technology, they are looks like isolated, right? Sometimes they even don't communicate. All right. So whatever in their mind, then they make a conclusion, right? So those days we can see there are more discussion, something like this. Am I right?
Yes, bro.
Okay. How about this one? Al-Walid is here. Al-Walid Hassan.
Yes, doctor.
What do you understand about this photo?
Okay, in my opinion, I see mm, uh, the first family can communicate it good with each other without individual phone and not effective for technology. Not like the second picture.
Yeah. So they are divided. So each of them with the phone and then busy with their own business, right? Whereas over here you can see that they are focused, right, in one thing, and they are very united, right? So there are pro cons of the technology, good or bad. All right. Okay, how about here? Okay, we have over here Harshini is here. Harshini, Yellow Malay.
Yes, doctor.
Harshini, what do you understand about this?
How the technology have changed the people from 90s and now in 2017.
How it changed?
before this in 90s, the television was big, which means we was healthier. Now the technology makers are not healthy as well in 90s.
Okay, because everything is slim, very light. People want easy to carry. People don't want to do much work. Even vacuum cleaner, you have AI vacuum cleaner, right? You have AI vacuum cleaner at the home?
No, doctor.
No, you have a vacuum at the home or not?
Yeah, just a normal vacuum.
Normal vacuum, but normal vacuum you have to push there and here, right?
Yes, doctor.
If AI, you just leave it, it will go right. So people is those days they are slim, right? So that's why you have all type of vacuum, so you are slim. But nowadays, we can see that things are very light, very small, so they are lazy to move, right? Then they fat, nah, fat. Okay, how about here? Jishnu? Jishnu is here. Jishnu Kesavan. Mana Jishnu?
Yes, Prof.
What do you understand on this photo?
On the first photo in 1996, the son wants to play the football, and the mother doesn't let him. And then to the current one, the son is more focused to video games, where he's become more lazy to go and play sports, and decided to play video games instead, which makes him
Ah.
more lazy and unhealthy too.
Yeah, right. Those days, people always stay at home, always go out. Even Raya time, those days, they go to friend house, they go outside, they go visit and so on. But nowadays, they don't like to go out. They like to stay at home, right? Uh, those days, even in university, people like to come to university and study and so on. But now, they say, never mind, we want online, we want to stay at home. So you can see a different now, right? So this is because of the technology, right? For the football, he can play in his handphone. So he's thinking why he want to go out, right? But mother wanting to go out because have need some sport activities and so on or whatever. So this is a good or bad about the technology, right? So since this is similar to what we have just now, okay, and then those days people are united, right? But now with the gadget, they are busy with many things. So even want to take care of the mother also, uh, they push to someone and so on, right? Okay. Okay, Muhammad Danish is here. Muhammad Danish. Danish,
Yeah, doctor.
what do you understand about this photo?
Oh, when 2009, people used to play kites. Now the technology is advanced, so some kids are playing with drones.
Yeah, now the drone. So there are not to say that the disadvantage or bad. This is something good also. While flying the drone, you can have many sensor, and then from the sensor we can observe things, can monitor something, and so on. So there are many things. You can see the changes of the technology is either good or bad. Hamineshwaran is here. Hamineshwaran.
Yes,
Hello,
doctor.
what do you understand from this picture?
In 1996, when people fall down, they try to help to save him. Until the 2016, we are taking for pictures for the video, stuff like that.
Okay.
The humanity is decreasing now.
Yeah. So people they just take photo, they just take video because they want to send to others, but very less people trying to really go into the problem and solve the problem and so on. Can see over here, all right, many things. Even if you are at the highway, if anything happen, accident or something, you see that people queue, very long queue, not because they want to go and help, but they want to take picture and they want to viral and so on. Correct or not? If anything happened to you, so you don't know, or you to say that the technology make people selfish or what. So this is the bad or good about the technology that we can think of it. Is it correct or not? If you go to the highway nowadays, you can see very less people have, but there are many people there. Correct or not? Plus,
Yes, doctor.
so this is the effect of the technology, and then this is what I want you to do to focus more in this week lab on the lab work. Okay, so if you can see here another lab work that I give you, you have to conduct self-study, individual, and you have to answer this question. All right, what you understand on how our brain works, and then how data is mapped in biological neuron or our mind. Few things that I have covered in my lecture, right? And then how humans store data and retain in their memory. What you understand with the following diagram. Okay, if you can see over here, retention of data in our memory through many things, right? So you have to give your understanding about this picture. And last but not least, technology is used to store data in devices, but how to retain them in our memory. Okay, so this is the field work or lab work that you have to do this week. Can you not? Class?
Can, Doctor.
All right. So this is our lab work. What else? Okay, let me continue a bit on mathematical modeling. All right. Okay, so mathematical modeling, there are actually three basic important components when creating a functional. They are actually, you can see over few lectures that I have given. There are synapses of the neuron are modeled as weight or strength. So there are negative weight and positive value of the weight, right? So see the connection. Like the example I give you, you meet someone, so how important that person to you? If that person is very important to you, so the weight is strong that you can remember them and so on. But if that person is not very important to you, so it is kind of very very weak of the weight, or is a negative uh, form to you where you don't have interest. Why should you remember his name and so on, right? So the next two component model of actual activity within the neuron cell is the N adder, okay, adder submission, and then their respective weight, as I mentioned just now, and then we can have a linear combination, as we have mentioned, x1 times w1 plus x2 times w2 plus x3 times w3 plus up to xn times wn, right? So it's a linear combination. And then next we have seen on the activation function, okay, 0 and 1, -1 and 1 and so on, right? So this is the mathematical modeling. You can see over here, the formula. I think you understand the formula. I already briefed you about this formula for the last few weeks. All right. And then the activation function, this is a basic operation of artificial neural network involves in summing its weighted input signal into the output, and then it generates the output signal, right? And then typically the same activation function is used for all neuron in the net, okay? And then it acts like a squashing function, like you squash to the wall, and then see uh, based on how hard you squash into the wall, that hard will bounce back to your side. Okay, so that we can represent by the weight and so on. So this is the three types of activation function you can see over here. So this is either it will give the output 0 or 1, right? And then another one is in between, as I mentioned before, okay, between 0 and one, and then another one using exponent properties. Okay, so all this is the activation function. All right, so this is the activation function. Okay, like this one is maybe you can see sigmoidal function. It can be many function, like bell curve or normal curve. If your marks, for example, your mark, I know already, right? We know that for this subject, at the end, we know already the marks. There will be few people fail. There will be few people got a very good marks, but the rest will be in between. So it is a bell shape of curve, right? So this is the many activation function bell curve. Is that uh, uh, fail is few fail, pass with the outstanding, a plus, for example, a few, but in between will be many. Okay, will be many. So it's a bell shape kind of function. Whereas we can see others like for our salary, for example, at the beginning very low, and then expenses very low, and then slowly it increase and so on. So that is the on the activation function. All right. Any question, class, so far?
No, doctor.
No. Okay. Next, if you can see at this curve, this is the hazard function and failure rate, right? Okay, this is on the human life, human life. At the beginning, when we born, okay, there are very high risk to the baby, right? High risk. This is the risk, hazard. HT is the hazard, and then if you can see my y-axis is a t, is a time. Okay, so at the beginning when the baby born, right, we can see very high risk. Anything can happen, any sick, right? And then if you have to go and take the immune hepatitis and so on, right, until come to the certain age, right, of the baby, uh, they are steady, or they are steady, or at a very safe, very less hazard or less risk. Same like you are young, you are healthy, you are strong. But when you getting older, so there are a lot of disease will come. For example, diabetes, blood, the pressure, okay, and then heart problem and so on. So the risk is shoot up, okay, shoot up until they die. Okay, so this is the human, we call it as like a bathtub curve or life curve, right? So same goes to your memory actually, right? At the beginning, we teach the children about the word, about the number, about the language, and so on, right? So you learn, then you get, but the learning is another curve, another way, from the bottom is go up, and then at the steady state, then slowly at the end of your life, you will tend to forget many things. Your memory loss. People will lose their memory, right? So until they forgot, they forget everything, become like baby again. Do you understand what I'm trying to say here?
Yes,
Right?
doctor.
Yeah. So this is on this curve on our physical. But if you look at our memory, right, is the memory, you memorize many things, then up to certain age, then you will tend to lose your memory. Like Dr. Mahathir, right? You can see, right? Okay, did you see Dr. Mahathir video or any recent speech by him, class, or in TikTok? Our former Prime Minister. Can you see, how old is Dr. Mahathir? Class? Are you with me? How old is Kun
Yes,
Mahathir?
doctor.
Kun Mahathir. How old is he?
96,
He's
98,
no, he's already 100.
100. Okay.
He born in year 1925. Now is 2025. So 100 years. Did you see his video? Recent one in TikTok?
No, doctor.
No, any of you? He went to Pasar Ramadan. He went many places. Did you see his Facebook or what? Class?
Yeah. When he
Uh,
went to the Bazaar Ramadan. Yes, doctor.
yeah, right. So you can see if you compare those days when he was a prime minister, the way he talked, the fat and figure, he can remember many things, right? So that's our memory. When we are young, we are in our childhood, so our memory is very powerful. But slowly, the neuron in our brain will die, and slowly will forget many things. Okay, so there is about this curve that I put over here. All right. So that's about how our brain or our memory works, right? Anything? Wow, got sound just now. Got another lecture going on. Okay, class. I think now already 9:30. Okay, 9:30. I have almost finished the lecture until the mathematical modeling. Okay, this is the example of the calculation where you can transform this into the matrix, right? We have matrix x1, w1, x2, w2. So we have x, and then you have w. We have multiplication x1 times w1 plus x2 times w2 plus x3 times w3. Are you still remember the matrix class?
Yes, doctor.
All right, so same thing we can use over here. And then why we use activation function. All right, this is why we use activation function. Basically, because we have many hidden units, they need for nonlinearity to the network. So without nonlinearity, hidden units would not make nets more powerful than just plain perceptron. Okay, we learn about the perceptron later, don't worry. And then the reason is that a linear function of linear function is again linear function. However, it's the nonlinearity, which is the capability to represent the linear function that makes multi-layer network so powerful. Means that if we have linear function, okay, we have linear function, we product, we get one linear function, and then if we go again to this network, we will get another linear function. Then we product, we will get another linear function, right? That's what means by this statement. Okay. All right. Next, we are at the architecture implementation. I think now I already 9:30, almost 1.5 hours. You are with me. Can I cover this topic in the next class? Is it okay?
Yes, doctor.
And doctor.
Right. Yes. All right. So I will cover this in the next class. Okay. So our next class will be on 10 of April. I will finish the lecture on the lecture 3. All right. And then I think I finish early today class because I want you to complete all the lab given in week 1 and week 2. Can or not, class?
Can, doctor.
Right. And then make sure to start to do this lab work that I give to you this week one, the history of neural network, as well as the biological neuron and human memory. This is this week lab. that you have to do. Can or not, class?
Can, doctor.
I open until 12 April next week. So during the lab, so either today lab this afternoon or next week lab, okay, on 7, I want you to complete this. So we don't have any online or face-to-face lab session, but I already give you field work I want you to do. We will meet again on next week on 10 of April during our lecture time. Is it okay?
Okay, doctor.
Okay, bro.
All right. Do you have any other question that you would like to ask, class?
No, bro.
Okay, if no, just give me a second. I want to take the attendance, okay, for today class. Can or not?
Can, doctor.
All right, I already download the attendance list for this week. I think that's all. Please stay safe and then welcome back to UTM. I wish you a safe journey and Selamat Hari Raya, Maaf Zahir Batin. Probably today you are busy, want to go to Hari Raya function or any open house. All right, so I don't want to take more time from you. Please enjoy this Hari Raya, Selamat Hari Raya, Maaf Zahir Batin, and enjoy the holiday for non-Muslim. And please do revision on the slide, the lecture slide that I gave you, so that you should be able to complete the field work or lab work that I have given to you. And other than that, please complete this week lab as well and submit to ULearn. And I will see you again on next week, face to face, right? 10 April,
Yes, doctor.
Yes, doctor.
right? Face to face, I will see you again next week on 10 April. That's all for today. If you know other question, can we adjourn the class now?
Yes, doctor.
Okay, thank you very much and Assalamualaikum warahmatullah.
Thank
Bye-bye.
you, doctor.
Thank you, doctor.
Selamat Hari Raya, doctor.
Thank you, doctor.
Thank you.
Thank you,
Thank you,
doctor.
doctor.
Thank you, Dr.
Thank you, bro.
Thank you, Prof.
Thank you, prof.